Okay, I'm going to try and be as brief but thorough as I can here. So let's have a look at these graphs then. The first one will be strong acid and a strong base. So pH on the y-axis, and I'm going to add the base. So the line's going to go up as the pH increases. So this is the first of the graphs you need to learn. Starts at pH 1, ends at 13, and the midpoint is 7, and that's called the equivalence point, or the point of inflection, and this is the steepest point of the graph. And at that point, at the steepest point of the graph, the reaction's over, it's finished. Now just looking at the acid is pH 1, so the concentration of hydrogen ions is 0.1, and so it's a strong acid, so that was probably hydrochloric acid that I was using, at 0.1 molar, a monoprotic acid. Alrighty, let's move on to the next one. Again, pH, and this time I'm going to start with a weak acid and a strong base. So my line's going to start not at 1, but it's going to start at, in this case, 2.4. That's 0.1 molar ethanoic acid is 2.4. You've got to draw the line in. It took me a few tries to get it right, but there it is. The equivalence point, that's a little higher this time. The equivalence point is always shifted towards the stronger component, reactant. And that's the buffer zone there. So it's behaving like a buffer, because there I've got a lot of weak acid and not much sodium hydroxide, and that will make a salt and a weak acid, which is actually a buffer. So that part there is buffered. So reading down to the x-axis, I've got, let's say, 50 millilitres of the strong base was added there. And half of 50 is 25, and the point there is the half equivalence point. And if you read all the way across to the pH axis, the pH there is equal to the pKa of the acid. So let's have a look at that a little more detailed. This is an equation you need to know, and when the concentration of the base and the concentration of the acid are the same, well, that's called half equivalence. You're halfway there. I'm going to cross that, I'm trying to cross this out, because eventually log x over x, or whatever the number is, if it's the same, that's 0. So the pH is pKa. Moving on to another graph. Let's try strong acid and a weak base now. So my strong acid, I'm going to start at 1, and if it's a weak base, I'm actually going to end at 11.6. Sodium hydroxide is partially dissociated. It's a weak base. Okay, I'm going to draw it in. Now notice there's no buffering this time. At no stage is there a weak acid or base and its salt present. The point of inflection, or the equivalence point, is again there, and it's shifted towards the stronger reactant, so it's shifted towards the acid. It's below 7. Another graph. So this one here is weak acid and weak base. So it's just kind of a squidgy line around the 7. It's really hard to tell where the point of inflection is there. And it's hard to know if your reaction's finished at this point of inflection because you can't find it. So you've got to use conductivity measurements in order to work it out. The conductivity is the highest at the point of inflection. One more graph. So this time, I'm actually going to add acid before I've been adding base. I'm going to add a strong acid to a weak base. So starting off with a weak base, I'm trying to draw a little wibble there to show yet another buffer. And we end up at pH 1, which is essentially just the acid and its salt. So the point of inflection again is below 7. It's towards the stronger chemical. There's the buffered zone, because I've got more weak base than I do have strong acid, and that's what I've made a buffer with there. So the pH is resilient to change there. The buffer zone, it refuses to change when I add the acid. And looking at the point of inflection again, let's go halfway from 50 to 25. And reading along, I'm reading up there pH 9.25. So there's a little more sophisticated with the base. If the pH is 9.25 at half equivalence, then the pOH has got to be 4.75. pH and pOH is 14. And then that's the equation, similar to the one for acids and pH. So the pKb is actually 4.75. That's good, it worked. Whew, what a long video. Hope it wasn't too fast.